Assalamu alaikum, dear students. Welcome to Nuclear Physics lecture. I'm Dr. Parvez Ahmed, and this lecture we will talk about nuclear reactors. So let's start our lecture on nuclear reactors. Uh, Before going to formal discussion of the nuclear reactors, let's have a proper definitions of the nuclear reactors. So, what is a nuclear reactors? Uh, A nuclear reactor, which is also formally known as an atomic file, is a device used to initiate and control a fission nuclear chain reactions. I mean, this is a formal definition for a nuclear reaction. I mean, we can also have a definition for the nuclear reactor, it's a device or it's a place where we can perform a control nuclear chain reactions. I mean, the chain reactions might be fission chain reactions or might be fusion reactions. Uh, Nuclear reactors are used at a nuclear power plant for electricity generations and a nuclear marine propulsion. I mean, this is the common use of the nuclear reactors. So, fission is used and nuclear power reactors since can be controlled while fusion is not utilized to produce power. Why fusion is not utilized and why fission is being utilized? It's because the fission reaction is not easily controlled and it's expensive to create the needed conditions for the fusion reactions. I mean, it's not only whenever we are talking about the nuclear reactors, so by nuclear reactors, mainly we mean a fission reactors. Why fission reactor? Because a fission reactor, it can easily be controlled. And why not fusion reactors? So it's because fusion is not utilized to produce power. I mean, we utilize the fission reactor for the productions of the power and for nuclear marine propulsions. But we cannot utilize it. We cannot utilize it by using the fusion reactions. Why? Because fusion reaction is not easy to control and it's expensive to create the needed conditions for the fusion reactions. So what does mean when we are talking about the control nuclear fissions? You can easily get the idea of the control nuclear fissions by having a look at the figure. I mean, in the figure you can see that we initiate a fissions. By a neutrons by a neutron bombardment. We bombard a neutrons on the target, which is a uranium 235 nucleus. So as a result of that, you know that we have discussed it previously that we produce fission fragment, and as a result, we also have 2 to 3 neutrons. So if we are interested in control fission, so what actually we do? So out of the 2 or 3 neutrons, we utilize only 1 neutrons for the further fissions, and the other neutrons they are being observed. How they're being observed? I mean, we use different moderators or absorbent to observe the extra neutrons and allow only 1 neutron out of the 2 or 3 neutron which been produced as a result of the first fissions. The same is being continued for the second generation fusion, third generation fusion, and so on. So this is the key idea for control nuclear fission reactions. So what actually we have as a requirement, and a requirement only one produced neutron per generations can strike another uranium nucleus. I mean, that is the key idea for the control nuclear fission reactions. So then we have type of the fission reactions. So what are the key type of the fission reactions? And type of the fission reactions, we have light water reactors that simply we denote by LWR. That include pressurized light water reactors that we have the abbreviations PWR. stand for pressurized light water reactors. The second type in light water reactors, we have boiling water reactors that we have abbreviations BWR. The second type of the reactor, the fission reactor, is breeder reactors. So these are the two main kinds of the reactors that's been utilized for the control of fission. So let's first talk about the light water reactors. So be remember, this kind of the reactors is mainly used in the United States of America. Uh, and this kind of reactors normally utilize water as a coolant and a moderator. I mean, it's a light water reactor. This is mainly used, very commonly being utilized in the United States of America. And in this kind of reactor, normal water has been used as a coolant and as a moderator. So this is the structures of pressurized water reactors, which is, one of the kind of light water reactor. So here you can see a different part of the reactors. This is a main reactors areas. I mean, it's a reactor vessels. I mean, this whole area is called containment structures. Inside the containment structures, we have stream generators. We have coolant rod. This portion is, the pink color and pink is a reaction area. I mean, it's a reactors, and that we call the reactor vessels. Here you can see that it's the form, and on the right hand side it's a cooling towers. It's providing liquid which is being the water provided to here this particular area, the blue area, and this particular the main purpose of this is it's product producing cooling, condensed and cooling water. And here we have the turbines, and the turbines being linked with the generators. Here we produce steam, a steam generator here. This is a steam generator line. So PWR has three separate cooling systems, just like you can see it here in this particular setup. Only one should have radioactivity. I mean, out of these three cooling system, uh, only one should have a radioactivity, that is the reactor coolant system. Uh, if you look inside the containment structures, so inside the containment structures will look like this. You can see it here. It's a sampler nuclear reactors. Here you can see that we utilize the control rod and the fuel rods and moderators. Here you can see that this the fuel rod, which might be uranium 235, or maybe in some cases the plutoniums. Here you can see that means the outer walls, the outer lines may indicate the radiation shields. So here you can see that in these lines, the metals, we have the coolants, that they're basically being the waters. Here this particular area, I mean, it's like the resistance science is basically for the stream, and this is for the heat extinguishers. So area the arrow signs there, this particular area is the form and the forms and billows that operate basically the coolant. So the fuel rod, I mean, which being utilized here, uh, is basically uranium 235 with enrichment from 3 to 5%. I mean, here's the fuel that we utilize here. It's uranium 235 being enriched, 3 to 5% is being enriched. Uh, Plutoniums and alloy or oxide form can also be utilized as a fuel. The control rod, I mean, here you can see here the black and black, these are the control rod, which in this particular form it can be cadmium or graphite raised. I mean, these rod, they are being raised or lower to change the rate of the reactions. I mean, the rate of the reactions, it depend upon the conditions of these control rod. I mean, if you want to increase or decrease the reaction rate, or you want to accelerate or decelerate, so what actually you need to do, you just have to move these rods. I mean, you can lower or you can raise these rods in order to accelerate or decelerate the reactions. I mean, with the help of these, with the movement of these rods, I mean, the reactions totally depend upon the movement of these rod control. That's why they're called controls rod. So here in this particular structures, the coolant perform two functions. What are those functions? Two functions. The first function is, I mean, that the coolant perform is that it keeps the reactors cool from getting too hot. I mean, you know that the fission reaction is being performed, and as a result of that, it can get hotter and hotter with the passage of time. So in order to cool, uh, to keep it cool, so we utilize water, and water as water is being utilized as a coolant. So the main functions for the coolant is to keep the reactor cool from getting too hot. I mean, here, I mean, we're trying to keep it safe from getting too much hot. And the second function is to transfer heat which drive turbine. I mean, this the two functions. These are the two functions being performed by the coolant utilized in the reactor. So while utilizing water as a coolant, we should remember that in light water reactors, I mean, we utilize ordinary waters, need enriched uranium fuel. I mean, these are the requirement for the light water reactors. I mean, if let's suppose you have light water reactors, or you want to run the light water reactors, so what actually you needed, these are all the things you needed, and that is the light water reactor. It uses ordinary waters. It needs enriched uranium fuel, and this kind of reactor is commonly been in use in the United States of America, and it contains almost 80% of the world's reactors. I mean, if we say that there are 100% reactors in the world, total type of reactors in the whole world is 100%. So out of that 100%, 80% of the world's reactors consist of light water reactors. So heavy water reactors, if you talk about heavy water reactors, so heavy water reactors uses DTO, that is, it utilizes heavy waters, and this kind of reactors can use natural uranium. I mean, it's unlike the light water reactor where we need enriched uranium fuel. Uh, the heavy water reactors can use a natural uranium, that is, it can utilize uranium 238. And heavy water reactor is most common in Canada and Great Britain. And this kind of the reactor, it consists of 10% of the world's reactors. I mean, 80% of the world reactor consists of light water reactors, and only 10% of the world reactors consist of heavy water reactors. Pressurized water reactors. I mean, in this kind of reactor, we use a heat exchanger. Uh, and this kind of reactors keeps water that passes the reactor core and a closed loop. Uh, Similarly, steam and the turbine never touch fuel rod. I mean, this is the, I mean, it's some of the characteristic are, you can say that advantage of pressurized water reactors. Boiling water reactors, and boiling water reactor, no heat exchanger. I mean, boiling water reactor, no heat exchanger is needed. Water from the reactor core goes to turbines, and sample this kind of reactors is very simple in designs, greater, but it contain or it has greater contamination risk. So this is a comparison between the two kind of the reactor that we already discussed on the previous slide. That is pressurized water reactor and boiling water reactors. So it looked like pressurized water reactor. This is the example, the sketch, the inside structures of the pressurized water reactors. And the below one, this one is the boiling water reactor system. So the feature that we discussed on the previous slide, I mean, you can visualize or you can note it by note it for your own self. I mean, this is the comparisons. So you can do the comparison just by having a look or having complete look on the discussions we have on the previous slide. For further detail, you should either go to some of the website in the internet, or you can watch some of the videos available on the YouTube. You can study the details and some of the useful book available in your college or school libraries. So, what are the moderators? The main moderators which are being utilized and reactor for slow down the reactions. You know that the moderators, they are being very much very important to be utilized. Why it's being utilized? Because they are being necessary to slow down the neutrons. When a neutron is being slowed down, so it's mean that the moderators, they are very much needed in order for the reactions to be controlled. So the probability of causing a fission increases with a slow moving neutrons. Light waters will capture some neutrons, so enriched fuel is needed. Heavy water capture far fewer neutrons, so don't need enriched fuels. Uh, what are the breaded reactors? So breaded reactor generate more fissionable materials than they consume. So the fuel that can be utilized in breaded reactors is mostly uranium 238, uranium 235, and plutonium 239. So these are the main fuel that can be utilized in breaded reactors. No moderators used. I mean, it's in breaded reactors. There is no need for the moderators. So what it mean? It mean that fast neutron captured by uranium 238. It produces uranium 239. Uranium 239 decays to fissile uranium 239. That's why no moderator has been needed. Why is that there's no moderators? It means that the natural occurring uranium, that 238, has been converted to uranium 239, which then decays to fissile plutonium 239. Uh, Coolant and this kind of the reactor is liquid sodium metal. Uh, and this kind of reactors is not common in the United States. I mean, none of these reactors is there in the United States. So it's mostly being used in France, Great Britain, and Russia. I mean, it's bread reactors that are being in use in France, Great Britain, and Russia, and none of these are in use in the United States. So, what are the advantages of the breaded reactors? Uh, One of the advantages of the breaded reactor is it creates fissionable materials by transforming uranium 238 into plutonium 239. I mean, this is one of the key advantage of the breaded reactors. Similarly, fuel less costly since it can transform uranium 239 to plutonium 239. So as results, we say that fuels less costly as compared to uh, uranium 235. So what are the disadvantages? The disadvantages, since one of the main disadvantages of this kind of the reactors is that since this kind of the reactors no need for moderators. So when no moderator is required, so if something goes wrong, so it happens quicker. I mean, normally you know that in light water reactors we utilize moderators or absorbent in order to control the reactions. But in breeder reactor, we are saying that there is no need for moderator. So it's one of the biggest disadvantage of this kind of reactor. So here we are saying that if something goes wrong, just because of the absence of moderator, so it happens quicker. So it will be a disastrous. The next advantages, that is this kind of reactors it utilize liquid sodium, and you know that liquid sodium is extremely corrosive and dangerous. Plutonium, the third advantage is plutonium critical mass, that is 50% is smaller than the uranium, so most widely used for weapons. I mean, this kind of reactors is most widely used for the weapons and more actively sought by the terrorists. I mean, this kind of reactors, since the most widely used uh, for the weapon, so this why it can be actively sought by the terrorists. Fuel rod, it's required periodic reprocessing to remove contaminants resulting from the nuclear reactors. So cost considerations can be a problem. So that's all we have for the nuclear reactors. So see you in the last lecture. Until then, bye bye.